Okay, ladies and gentlemen, let's do the second example, which is 11b. Now we have x in terms of y. So here we go. I already graphed it. So let's shade the region enclosed by the two graphs, which is this one. Notice we have parabolas again, and the area above the x-axis is the same as the area below the x-axis. So instead of going from this point of intersection down here to this one up here, we're gonna go from 0 to this point, this one here. So now we need to find it. To find it, we need to set the equations equal to each other. So here we go. So it'll be y squared equals 2, 16 minus y squared. Let's isolate the y squared, so it'll be 2y squared equals to 16. Divide by 2. Y squared equals to 8. Square root of both sides, we get y equals plus or minus square root of 8. This is my point of intersection. That means that they intersect at y, negative square root of 8, and at positive square root of 8. Now, like I said, the integral, we're only going to look at this area here. So we're going to go from 0 to the square root of 8, and at the end, we're going to multiply by 2. So let's set up that integral. So area equals 2, the integral from 0 to the square root of 8. Now we need to look at the function that is farthest to the right. That would be the red one. If I go from right to left, it's the red one all the time. So that one's going to go first. So it'll be brackets, parentheses, 16 minus y squared minus the function furthest to the left. That would be this one right here, which is y squared. And we are going to integrate with respect to y. Now before we do that, we can simplify a little bit. So 2, the integral from 0 to square root of 8. My integrand becomes 16 minus 2y squared dy. Now we are ready to integrate. So 2 antiderivative of 16 with respect to y is 16y minus 2y cubed over 3. We're going to integrate from 0 to square root of 8. Now, if I plug in a 0, I'm going to get 0, so I'm going to ignore it for now. So just the square root of 8. So 2, 16 times square root of 8 minus 2 square root of 8 cubed over 3. This time we can use the calculator. And if we use a calculator, we get 30.170. That would be the area between those two curves.